All right, continuing with section 8.2, a couple more examples of the cotangent graph. All right, here we go. So just dive right in with this one. So we have the stretch. So the number in the front is 3. Okay, we have a period length of pi divided by the number in front of the x. So there's a 2 there. Phase shift. Okay, so there is that extra stuff in there. So remember, you always take the argument and set it equal to 0. And you can find out what the phase shift is. So negative pi over 2. So negative pi over 2. Okay, and whenever that happens, I do like to show the alternative way of writing this because it is a very common way to write these with the b factored out. And so dividing both of those by 2, we get plus pi over 2 like this. Okay, and so when it's factored out like that, the plus pi over 2 tells you exactly that it's a phase shift in the opposite direction of that. Okay, but when that's not factored out, then you have to have the argument set equal to 0. Okay, the vertical shift. Okay, so there's that minus 2 in the back. Okay, and then let's go ahead and do our interval. So cotangent is between 0 and pi. So 0 less than or equal to the argument, less than or equal to pi. Solve for x in the middle. Okay, so that's weird. That turns into a 0. And then now we've got divide by 2 everywhere. And so we have negative pi over 2 less than or equal to x less than or equal to 0. All right, so that tells us the start and end of one period. So let's label that. Everything's happening on the left-hand side with a stretch of 3. So maybe I want kind of a tall y-axis with everything happening on the left here. Okay, so negative pi over 2 and 0. So those are the endpoints for our asymptotes. Okay. The center. Okay, so that's going to be negative pi over 4. Pretty easy to get that one. For this one, divide in half again, negative pi over 8. And so let's see, negative pi over 8, negative 2 pi over 8, negative 3 pi over 8, negative 4 pi over 8. So that's the fast way of finding that. But again, you could always just add up the 2 endpoints and divide by 2. Okay, let's see. We've got the negative 2 is the vertical shift. So I'll go ahead and do a little dotted line down here and call that negative 2. Okay, we know that the middle is going to be right on the vertical shift. Okay, now we have to do the stretch. So we know that it's going to go 3 above. So that's going to go to 1. And it's going to go 3 below. So negative 2, and then 3 below that will be negative 5. So those are going to be the locations of the quarter points. Let's see, we've got a positive number in front. So cotangent starts high and goes low. So at the first quarter point, it's going to be at the high part. At the second quarter point, it's going to be at the low part. And then just go ahead and connect these through. Try to make it curvy. Try to make it look like it's approaching those asymptotes, and you're done. All right, hopefully this is starting to feel a little bit faster, a little bit more procedural. You start to really get the hang of it. All right, let's do another one. So again, I'm going to write down the stretch. So, okay, so this is kind of a weird one here. There is like this minus 1 in front of our cotangent. So I'm going to put absolute value of negative 1 and then make a note that it's upside down. Okay, important to note that it's upside down. Okay, period. Okay, so the period is pi divided by the number in front of the x, which is pi. So that's weird. Okay, the phase shift. Okay, remember, take your argument and set it equal to 0. And so let's see, we get x equals, if I add the pi and divide by pi, x equals 1. So the phase shift is a positive 1. And again, whenever it has that, I do want to show you the alternative way to write this with the pi factored out. Okay, so with the pi factored out, there is the -1 in there for the phase shift being the opposite direction. Okay, always want to show you that extra version because it's very common that we have that b number factored out. Okay, and the vertical shift. So there's this 1 in the front. Okay, this 1 means we do have a +1 in the front. Okay, let's do our interval. So from 0 less than or equal to the argument less than or equal to pi. Okay, that's how cotangent works. Then we add pi everywhere. We don't want to solve for x in the middle. So we have pi less than or equal to pi x less than or equal to 2 pi. So this is one of those weird ones where there was a pi multiplying on the x. And so now we've got our interval is just whole numbers, which seems a little bit tricky and stuff at first, but once we start trying to graph it, it actually makes it easier, in my opinion. Okay, so let's get a graph going. Everything's happening phase shift off to the right-hand side. Okay, so it's all happening on the right-hand side. So from 1 and then over to 2. So these are where the asymptotes would be. Okay, at 1 and 2. Okay, what's the middle of 1 and 2? Yeah, 1.5, but I'd prefer to write it as 3/2. Okay, what's the middle of 1 and 3/2? I'd like to write it as a fraction, so 1/2 times 1 plus 3/2 is 1/2 times, that's 2/2, that's 5/2. And so what did we get? 5/4. Okay, so let's see if I can count. That's 1 would be 4/4, 5/4, 6/4, 7/4. And then 8/4 is the 2. All right, so there's all of the quarter points. Let's see, we've got that phase shift. Okay, vertical shift is +1. So I'll go ahead and do 1. Okay, and then we had that the stretch was just a regular 1. We'll take care of the fact that it's upside down, but since it's just a 1, it means it's going to go up by 1 from the vertical shift and down by 1 from the vertical shift. Okay, so the center is right through that vertical shift. Okay, this is upside down. Okay, so this is maybe a little bit tricky because you might already be thinking that cotangent is like an upside down version. So remember that cotangent, it starts high and goes low, but since we're upside down, it's going to switch that around and it's going to start low and go high. So then it ends up looking a lot like the tangent graph. Okay, very important to make sure that you've got cotangent, which already feels like it's an upside down version, but it's an upside down version. Okay, so it switches it back and it makes it look a lot like a tangent. Okay, and that's a really important thing to notice because if you were ever going to do, and I've got some examples at the end of this lecture, of trying to come up with the equation of a graph or from a picture, and you have options. You can make it a cotangent or you can make it a tangent depending on what kinds of shifts you want to use. Okay, so I'll make a new video to pick up with the secant function.